So we will get this relation that total electric flux is equal to the amount of charge enclosed by that surface, or we can write this in integral form because this electric displacement or electric flux phi is equal to, we have written here, d dA cos theta. So we can also write this like this: closed surface integral d dot dA. And we can also write for this surface is closed surface by double integral sign like this, double integration. So this is the, in the, you can say the integral form of Gauss law. You can write this is equal to d dot dA is equal to q. So and this Gauss law is when we have discrete charges, charge or charges. So if we have, for example, if we have nth charges q1, q2, qn, then we can rewrite this relation like this: d dot dA is equal to q1, q2, q3 plus qn, summation of all charges. So this is when we have discrete charges. And if, for example, if charges are not discrete in this surface, or you can say the charge distribution is continuous. Now if charge distribution is continuous, that we can't able to distinguish between q1, q2, qn. So in that case we can replace this charge q with the density, or we can write like this: volume integral of rho into dV. This is the volume charge density. Rho is volume charge density. This is charge density, and we can rewrite the integral form which we have written earlier: d dot dA is equal to q. We can replace it with volume integral rho into dV. So this d dA is equal to volume integral rho into dV. This is the integral form of Gauss law for Gauss law in electrostatics. Now we will write the differential form of Gauss law. So in order to write the differential form, we will use the Gauss divergence theorem. So according to Gauss divergence theorem, or we can say this theorem relates the surface integral, closed surface integral, if we have A is a vector quantity, dA is the area element. So this is equal to volume integral of divergence of A into dV. So this is the statement of Gauss divergence theorem, and we know that the integral form of Gauss law is d dot dA is equal to volume integral of rho into dV. Now we will use Gauss divergence theorem. Use Gauss divergence theorem in this, in the integral form of Gauss law, that is d dot dA. We can write this is equal to volume integral of divergence of d into dV, and we know that this quantity is equal to this, which is equal to rho dV, or I can write this is equal to divergence d into dV is equal to rho into dV. So left hand side and right hand side we have same integrations and same volume element, so this reduces to divergence of d is equal to rho, or I can write like this, divergence d is equal to rho. So this is the differential form of Gauss law in electrostatics, and this is the integral form of Gauss law. So this is all about the Gauss law.